Can you hear me, guys?
Yeah, sir, we can hear.
Okay. So maybe we should wait for another couple of minutes and let's more people join in and then we can start.
Okay, sir.
Okay, it looks like it's 5 minutes after 11. Shall we start? Hello. From NPTEL.
Good morning, sir.
Yes.
Can you mute your speaker, sir? Volume low because it's echoing.
Is it better now?
Yes, sir. Better, sir. You can go ahead, sir.
Hello.
We are on live. Yes, sir. You can go ahead.
Is it better now?
Hello, sir. Hello.
Hello.
Hello, sir.
NPTEL team, can you hear me?
Yes, sir.
Message.
Okay, looks like I'm not sure if NPTEL can, I think people can hear both me and NPTEL, but I'm not sure NPTEL team can hear me. Yeah, NPTEL team, I think you are muted, so we can't hear you probably. Okay, I reduced my volume. Is it okay now?
Yes, sir. No, okay, sir.
You can.
Sir, you can increase one
Hello, NPTEL
volume,
team.
sir.
Hello. Can you hear me, NPTEL team?
Yes, sir. Yes, sir.
Shall,
Hey, professor number and render device join device.
it should work. Maybe I will just restart my, increase the volume. Is it better now?
No, okay, sir. Hello.
Let me just leave.
NPTEL team, I can hear you.
Yeah,
I can
yeah.
hear both
But
sir
sir
and
only is not
I
hearing.
think, I think he has muted his speaker since you told, right? It's echoing.
yeah,
So he has muted his speaker. So probably we can let him know that he can either use his headphone or, lower the sound of the speaker.
Yeah, we have to do is lower the sound because it's echoing. That's why.
So can you call him directly if you have his
Yeah,
number?
yeah.
Because, please call him
We
directly.
are calling. We are calling.
Thank you.
Okay, can you hear me now?
Yes, sir. Yes, sir. We can hear you. You can hear us.
Hello?
Hello. Sir, can you hear us?
Can you hear me now? Yeah, hello? Yeah, I'm I'm already increased it.
Volume.
It is at the highest at this moment.
Can you hear our volume, sir?
No, I can't hear anybody.
But students are here both, sir.
Huh?
We can hear you clearly, sir. Please
Let
go
me
ahead.
try. Let me try my headphone. Okay. Okay, yeah. Okay, just a minute.
Sir, can you hear us, sir?
Okay, I think.
Hello. Hello, sir.
Can you hear me now?
Yes, sir. Clear, clear.
Hello? Can you
Oh,
hear me now? Or I will just join by my tab, and I don't know, for some reason this my desktop system is not working. Okay, I'll join by my tab.
sure, sure, sure. Okay, sir.
Can you hear me now? Hello?
Sir, can you hear us? Hello, sir.
Yeah, can you hear me now?
Yes, sir, we can hear you.
Okay. Okay, I think we can start now. Right?
Yes, sir, we can.
Right? Yeah. Okay, so I think, yeah, it's sorry for all the technical glitches, and welcome you all to the, live session, first live session of this NPTEL course on predictive analytics, regression and classification. So I hope you have gone through the the first material for the first week, or first and the second week as well. If not the second week, at least the first week of material you have gone through. And few of you have asked me question on the discussion forum. I tried to answer a couple of questions that I found. Uh, I will try to answer those questions, and then if anybody have any question, please feel free to ask those questions. And after that, the TA for this course, Tanika Shah, is also here. She will do about 15-20 minutes of session on hands-on. And then, of course, anybody have any question, feel free to ask her or me anytime. So either you can write your question on the chat box, or just raise your hand. So yeah, just grab our attention. So let me first try to share my screen. So I think one of the question was that in the design matrix, if you look into a design matrix, typically this is our typical linear regression model. And in the design matrix, first column we are keeping as like 1, 1, 1, and then x1, x2, all these feature variables are here, right? 1, 1, 2, 1p, and all the variables here, right? So this is how we are defining our design matrix typically. Now, question was why first column is always 1? Why first column is always 1. So this was one of the question I think I should try to explain. So let me try to say, so let me give you an example. Okay. So suppose consider a toy example of say y equal to a plus bx plus epsilon. So that means you have a x here and a y here,
10 जण आहेत चला पोरं नसतील.
and you have bunch of data points and you want to fit a line, and this line is essentially your y equal to a plus bx, and these errors are your epsilon. Okay. Now, if I want to, this is my simple model written in a simple way, but if I want to write it in a matrix notation, we want to write it in matrix notation. Okay. Now in the matrix notation, how we will do it? So first we can write it in this way: y equal to a times 1. A is just I'm multiplying a with 1 plus bx plus epsilon. Still no problem. I'm just writing this model as y equal to a times 1 plus bx. Then I can write this as a 1x transpose a b plus epsilon. So now you can see for intercept, I need a 1 here in the first column of the design matrix. Now naturally, so this is a natural extension. Now, how is it coming as a, for how many data points we have, say n data points, right? So we can write it in this way. Now we are extending it, the concept y1. For the first data point, we will have a plus b x1 plus error. Then second one is y2 a plus b x2 plus error, right? In this way, y n equal to a plus b x n plus error term. So now you see we are going to use this trick, okay, to form it in a matrix notation. So on the left side of the equation, we can write it in this way: y1 dot 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 yn. On the right hand side, essentially I'm going to multiply each of them with 1, and then I have 1 x1, 1 x2 up to 1 xn, and here I have a and b plus error e1 to en. So that's why in the design matrix, to accommodate the intercept part, we need to have a column filled with only 1. So, so this was one question. Do you have any other question? So, yeah. This was one question I thought I should explain to all. Anybody have any other question? Let me try, there was one more question. Let me just try to pull that. Okay, I think I got it. Let me just share my screen again. So, okay. So, in this was, I think, in the third or fourth lecture or part B of the second lecture, I think. So this was the example. In this experiment, this was the data, and we wanted to put it into y equal to x beta plus epsilon kind of mode. So this is what the whole thing is. Now what we can, the question was how we write the y's and x. So here I have like, how this is the way we actually, the first, if you see the data, this is the data that was presented. The first four, um, first column and first four rows, like, toxin 1, these all represent the category of toxin 1 in my entire data. So they're altogether 1, 2, 3, 4, 16 data points we have. So for 16 data points, here we have exactly 16 rows. And in these 16 rows, the first 4 rows represent toxin 1. So that's why all the, columns in the first column, first 4 rows were 1 and rest of the values were 0. So that's how the dummy variable or the indicator variable are being typically being created. And also this is called one hot encoding, typically in the ML data mining machine learning literature. Now the question was, I think, how the Y was created, and here is the Y. So if you see, basically what I have done here, if you go up, so in the data set, I just took the toxin 2 and put in the below the toxin 1, and then toxin 3 put below that. It like I just stack one over the another. And exactly that is what happened. 28, 23, 14, 27, and then 33 will happen. And you can see that when I go to Y, 28, 23, 14, 27, and then 3. So this is how the Y was created. So I think these two questions I thought I should discuss. There was some confusion. So now please feel free to ask me any question you have. So if you don't have any question at this moment, then I would request Kanika to present the hands-on analysis that she has planned. So she's going to use the diamond data set that is available in ggplot2 package in R. So what she will do, she will basically show you how she's going to do this like develop a simple predictive model or regression model using on this diamond dataset, and she will show how to do the predict the price of a diamond. And she will end of this session, she will share the code with NPTEL team, and they will make it available in the portal. Okay, so I think without any further delay, Kanika, it's to you. I think I will just.
Am I audible to the audience?
Yes, ma'am.
Hello?
Yeah, you are audible.
Okay. So let me share my desktop. Okay. So welcome all once again, the live session of the Predictive Analytics, Regression and Classification course. I am Kanika Shah, TA of this course. So pretty much we all know about what is predictive analytics till now, but still I want to give you an overview. So just a second. Okay. Okay, so what is predictive analytics? So yeah. So my screen is visible to you guys. Hello?
No, ma'am.
No, okay, okay. Let me try once again. It's not. Hmm. There is a problem.
Just a minute, let me see. Let's try this. No.
Yeah, now my screen is visible.
Yeah.
Okay. Okay. So sorry for the technical glitch. Yeah. So what is predictive analytics? So in the spectrum of the predictive analytics, 4 components are coming. The first one is the descriptive, where we are cleaning the data, we are relating the data, summarize the data and visualize the data. And we are trying to guess what is going inside of our business. And the second point is the diagnostic part, where we are drill down the data, we are discovering the data mining part and the correlation, how the variables are correlated to each other, like that. And the third part is our area of interest, that is predictive part. Here we are built up with a model. We're building up a model with using a lot of mathematics and try to refine and tune to the model. And the last part is the optimization part, where we are using this output of the predictive model to to make any strategic decision in our business. So this is the 4 component. It's coming in predictive analytics part. So the second slide is like we all know which kind of problems are belongs to the predictive analytics. Still, I want to give you 4 more example. So the first one is the predict the number of goods going to sell for every store. So like we all know that in departmental store, we have different section like bakery section, dairy section, frozen section. So can we predict how many product we are going to sell in the next month or in the next year? And with the predictive analytics, we can answer this question. And at the same time, we can answer how to support our supply chain so that we can manage our profit and how we can manage the profit in our business. The second example is predict the price of the diamond using the various features. This diamond dataset is available in ggplot2 package. You can download the this dataset in R. So given all the features of a diamond, can we predict if a new diamond is coming in the market, what will be the price? The third example is the patient mortality, that whether a patient will survive 1 or more year or not. Generally, the hospital collects the patient health parameter, which kind of the patient is going through, which kind of treatment, and what medicines are given to them. If we have all the reports of a particular patient, can we predict that this patient is going to survive 1 more year or not? The third example is the air pollution, that predict PM 2.5 in locality for a given period of time. That we all know that PM2 is a populant hazard parameter. It's going to be beyond a particular level. It is causing the health hazard. So if all the air related informations are given to us, can we able to predict PM 2.5 for a given locality? So all this kind of problems that belongs to the predictive analytics. Now let's move some basic terminology that we need to remember throughout this course. That what is sample size? Basically, the sample size is the number of rows. And what is sample or observation? Each row is a sample unit, or we can say it's an observation. And what is predictor? Predictor is number of columns or the independent variable, or we denote it as x1, x2, the feature. The feature of the data set is the predictor. And what is target variable? Our dependent variable, or we can say it's a response. We denote it as y. This is a small snapshot of the diamond dataset. I took it from R. So see here, each column is a feature of this diamond dataset: carat, cut, color, clarity, depth, table, price. XYZ is the dimension of diamond. Now the last line, if you see, it's put in red color. That this is, we can consider a new diamond in a market. So if a new diamond is coming, which we have all the information about that diamond, that carat, cut, color, everything. Can we predict what will be the price of this diamond? So this belongs to the predictive analytics. One thing I want to mention, that here each row is representing a unique diamond. We can think like that, that first row is diamond 1, the second row is diamond 2. Each row is the observation of a unique diamond. Okay, so any question? Okay, so can we move to the hands-on part? Okay. So these are the necessary libraries we need to this is the dataset, diamond dataset. Now, if we put the head of this dataset, it will give you the first 6 rows of the dataset where we can see that caret, cut, color. These are the dataset. Then STR is the structure of the dataset. The structure of the dataset is showing us how many numerical variables are there, how many factors are there, how many characters are there. So this all information, how is the structure of a dataset? It will show in STR diamond. This is the summary of a dataset. What is summary of a dataset? See, this is a caret. The mean value of the caret is 0.20. The maximum value of the caret is 5.0. The first quantile, that is 25% or below, is 0.40. And the third quantile or 75% or below is 1.0. Median of this caret is 0.70 and mean is 0.79. In this way, you can take the interpretation of rest of the column as well. So this is the dimension of the dataset. Dimension of the dataset is 53,940 is the observation and 10 variable is there. Names of the diamond will represent the column name of the dataset. Now we will see some visualization part in the diamond dataset. Let's see if we are plotting histogram of the price. See, this we are getting the histogram of the price, and we can see it's a positively skewed histogram. If we take the log of the same price, we can see this is a bimodal distribution. Now, we want to see the scattered plot of caret versus price using cut as a color. So let's see how this scattered plot will look like. Oh, this looks like non-linear relationship. Now, let's interpret it like this. Let's take a small spectrum like 1 to 2 in the x-axis. We can see if the price is in high range, all the premium and ideal cut belongs to the high range, which is obvious. And the fair and good cut belongs to the low price range. If we put the same graph in a log scale, we can see a log linear relationship here. This is another box plot of price that is grouped by cut. So here we can get assumption that more or less all except the ideal all price, their mean is in more or less same. Okay, in this way we can try to visualize the data and we will get a sense how our variables are, how their mean and average are, so that we can get a sense of our variables that we are working into. Okay, so now we are going to fit a simple model. For that, we need to split our data set into train and test. And usually in the industry practice, we are doing that 70% of the data set we are taking as a train and 30% of the data set we are taking as a test. So here I have split the data set into train and test. And here is my simple log regression model. I have taken only 2 variables. One is caret and one is color, one character and one numerical variable. So let's fit the model and take the summary of the model. Okay, this is the summary of my model. So you can see that first column is the estimate. So intercept minus minus 2146. This is our beta naught. Caret 8078 is our beta 1, and the rest of beta 2, beta 3, like that. The second column is the standard error, third is the t value, and the last one is the p value. And in the down, you can see the residual standard error, the degrees of freedom. The R square is 0.86, adjusted R square. All this information has given. Now let's see the design matrix of this model. So if we print this one, so model.matrix will give us the design matrix. And if we see that here is the design matrix. So let's do this one. Train. So if you see in the train data set, the first is EE, the both are E in color. If the design matrix you see, it's both E is 1. I mean, the first 3 are E. So in the design matrix, first 3 are 1. The fourth one is I. So in the design matrix, the color I is here is 1. So in this way, it is creating the dummy variable, or one-hot encoding it is doing. So here price is our response vector. We can take y as a response vector. And now the beta hat. Beta hat is the solution of the normal equation that we want to achieve. So if we run the beta hat here and combine it, okay, so what it has given? The beta hat is the solution of the normal equation, which we have calculated manually. Just two things I want to mention, that T is the transpose, and percentage we are using in R for the matrix multiplication. So it is not a normal multiplication. And we are C-bind the beta hat, which we have calculated manually here in the above line, and coefficient of M11, that is the beta that R has calculated. Now you can see the result. It's exactly same. I mean, the R is using OLS method in its to solve this equation. Okay, now see the standard error part. Now we all know that beta hat is following normal beta sigma x transpose x inverse. So getting to estimate the standard error, what we need the sigma hat. So how we are estimating the sigma hat? The square root of the sum y minus y hat divided by n minus p, where n is the number of observation and p is the number of feature or parameter, you can say. So in this way, we are getting the sigma hat. And here we are okay, just a second. Okay, so standard error, here we are calculating the standard error manually. How we, with given the formula, how we are calculating the standard error. And this one is the standard error calculated by R. So if we again C-bind the standard error calculated by R and we have calculated manually, we can see the exact match is coming in the standard error. In this way, we can check every parameter that how R is calculating and how we are calculating. R is exactly doing the same thing. But yes, definitely it has some inbuilt function. So we no need to do it manually. We can use all those functions. So this is another method of doing the standard residual error. You can try it out. I will share the code. And the last one is the confidence interval. For the confidence interval, we have calculated the t-score from the t-distribution, then margin of error, and then the lower bound and upper bound. And we have C-bind the lower and upper bound. This is the confidence interval of our coefficient. So here one thing to mention, I mean, how to interpret the result, that lower bound and upper bound. We can see everything is in same sign. I mean, if we check the caret, both are positive, the lower bound and upper bound. If we check the color E, both are negative. Here everything is same, but in case we are receiving like one is negative and another one is positive, like lower bound is negative or upper bound is positive, that means it is including 0. So that means that predictor has no effect in the model. In this way we can interpret. Here both are in same sign, so we can say it has an effect in our model. It is not including 0. So yeah, pretty much in this way we can interpret the result. Any question you have today? This much only I have to show.
Anybody have any question? Anybody have any question?
Okay. Muhammad Asghar.
Good question.
Yeah.
Can you, okay. So the Muhammad Asghar is asking, isn't necessary to scale the features and target? Good question. So yes, so if you have too many features, and particularly some features are at a very high range, say running in 10,000, 15,000, and some features are running in a very small range like 0.01, 0.02, 0.03. If the scales are very different of the features, it is good to scale the features. Means each feature or each predictor, you subtract them from mean and divide them by their standard deviation. And if you do that, what happens is your OLS estimator becomes much more stable. And this is a known fact. It was a good point. Now you can ask me why I have not done so, because these I think what happens in our, at least in this, these are like small data set, and generally it is working for this, but it might, I agree that if I would have seen that there are too many, the features are at a very different ranges, then it is better to scale the features. Yeah. So second is, yes, basically when we are using distance-based algorithm internally, we are rescaling on numerical features. Yes, I agree. Okay. Satyajit, thank you for the Yeah. Yeah, and Kanika will definitely share the code on the portal. So please have a look. Next session we will try to do on Python. Please do join. We will do a hands-on with Python. Perhaps we will share the Jupyter notebook ahead of time so that while doing while Kanika does the Python on the screen, you can also run it on your side. It will be more interactive. Yeah. Any questions? Any doubts? Theory side? I hope you have done the assignments also. You had no problem. If no questions are there, I think we can, I think it's now about an hour, so we can close the session, because I think if there are no questions or doubts, there's no need to drag on. One thing I want to tell you that typically, please, if you have any question, please ask on the forum in the portal. I try to answer it within 24 hours. If I'm traveling, in that case, I may be late, but either me or Kanika will try to answer the questions. So please write, if you have any doubts, please write in the forum, and we will try to get back to you within 24 hours. Okay, there is one question: which method is best suitable to calculate the future demand values based on the past weekly values? So that will be a time series model, and in the time series model, we can. I will. I think in the 4th week, I'm going to introduce some time series model. How can you use simple linear regression kind of model to develop something called autoregressive model? And you can use those autoregressive model to answer this kind of question, like calculate future demand values using past historical values or weekly values. So I think, yeah, next week, I think 4th, this is 2nd week, 3rd, I think 4th week, we are going to do some basically application of time series or regression model in time series, and or auto regression model. So yes. Any other question? That was a good question. So I think I should tell you guys one thing. One is there are 2 types of when we say predictive analytics, there will be 2 kinds of data set. One is cross-sectional data set, another is time series data set. Now, the data right now Kanika presented is actually a cross-sectional data set, because it's just a diamond, their feature, and the price is noted. But what time it was collected and at which date the price was the price, because value of the price can fluctuate over the time also, right? So time component is not recorded in that data set. So we will assume that as if all those 50,000, 3,000 diamonds features and the price were collected in one single point of time, maybe over just 1 week or something like that. So that kind of data set is called cross-sectional data set. Or that toy data set that I'm using for my typical, theory lectures, for the empty cars data set or the cars data set, that is also cross-sectional data set. But there are also time series data set where each data will come with with timestamp. Those data set are called time series data set, and that is typically when we handle time series data set, we try to do what we call forecast. So it's more like a forecasting problem. We want to forecast in the future. Whereas in the cross-sectional data set, we develop a data, develop a model, and given the feature, we want to predict the price or predict the, some like, whether somebody will have the disease or not. So this kind of questions we want to answer from the cross-sectional data set. So there is another question, is there any way to predict the model? Because for high dimension, any way to predict the model? Because for high dimensional data, we can't plot it to get an idea whether linear function is good to model it or okay. So basically, what kind of model? Sure. When I'm modeling, whether should we do it on, because when you're doing feature engineering, you're putting it in on the high dimension. Correct. Yes. So basically, that will come into the model selection, also known as variable selection, that we are going to discuss in the third week. So this is second week. In the next week, we are going to discuss variable selection or model selection. And there we are talking about, there are some model selection criteria like R square, adjusted R square, AIC, archaic information criteria, BIC, or root mean square error. These are the model selection criteria. You choose your criteria, and based on you do a model, like select a model. Then I have also discussed that bias variance trade-off based on because when you put more and more model, more and more engineered feature, what happens is your model complexity goes up. All these things I have discussed in the third and fourth week of lectures. And as the model complexity goes up, naturally, your model will have a tendency to overfit. So, and definitely you don't want to overfit your model, right? So, so in that case, what you want to do is you want to set up certain criteria based on which you want to come up with the best model. Yes, we want to predict which is the best model, and finally we want to predict based on the best model. I have discussed in detail how to do all those things in the third week, or the next week. This is the second week. Yeah. Okay, any other question? Very good question, Himanshu. Himanshu Jain was asked this question. It's a very good question. Yeah. Any other question? So I am seeing more students are pouring in. So maybe this 12 o'clock lunchtime, perhaps a better time, because I'm sure many of the students have other classes and they're joining from other classes, maybe next week. So please do, submit the form and tell your best choice of time. So maybe next week we will do sometime in the lunchtime when most of the colleges have no class, the lunchtime, and that time probably while, having a working lunch, we can do the session of discussion so that more and more students can join. Request there's a team for every live session. May you please also look into it. Some students also post questions there. Yes, definitely. As soon as NPTEL team shared that questions, I will definitely look into it. I have not received those questions for this week, but yeah, I'll ask those questions if they have. Yeah. Okay, here is a question by Saurav Biswas. How can we improve the process of predictive analysis? Good question. So there are two ways to improve process of predictive analysis. One is if you can bring more features in your data set. Okay. If you can bring new, like for example, the diamond data set that Kanika just presented before, it has about 8 features, right? But diamonds price also vary based on the source of the diamond, from which mine of which continent it was mined. If it is a South African diamond versus if it is a Indian diamond or a Latin American diamond, the price may vary quite a bit. Okay? So this information is not there in that particular data set. But if you bring that information also as a feature in that data set, then of course there is a chance, good chance, that your prediction process will go up. For that, what you have to do, you have to speak to the domain expert. You have to speak to the domain expert, the business expert. If you are working with, say, in academia, say with, if you're working in some sociology problem, then you have to talk to the professor of sociology who can tell you, you know what, this is a feature which typically has an effect on what we want to study. So you go and collect those features in your data set. That typically helps. However, this process is typically much more time consuming. So what you do if you have to have this kind of time consuming, on the other hand, if you suppose you don't have time to collect new features, okay, in that case, what you can do? In that case, what you can try is you can try some engineered features, some sign transformation or cost transformation or polynomial transformation. You can, there is some huge area of wavelet transformations. There is a huge area of spline transformation. As the course progresses, I will talk about these transformations. And as you try those things, what happens is if there are any, because end of the day, my data, most of the data is in a high dimension. Like if I have 4 or 5 features, we cannot really see how it looks in the 4 dimension or 5 dimension, right? So what we can do, we can try these feature transformations or, you know, predictor transformation or feature engineering and put them in a high dimension. And we hope that that will help us to fit a model which will do a decent job. I hope that answers your question. So here is Himanshu again. So basic doubt, a deep learning course. Regression is generally covered in 2-3 weeks, and they go directly to deep networks. You welcome, Saurabh. Okay, networks. Here in this course, doing mathematical and statistical analysis. Does it helpful for engineers from the viewpoint of developing improved algorithms, or so also help in solving real life problems? So Himanshu, it's up to you how you want to see it. So in the deep learning course, if you are in lot of hurry, yeah, I mean, that is where the money is, deep learning courses. So, you know, but if you see the deep learning neural network models, actually the deep learning neural network models, there are a lot of ideas are actually just extension of the regression analysis course or regression models. So regression model is the stepping stone. And in this particular course, we are focusing more on the theory and the hands-on with the with these models. Now, here is my experience where deep learning works and where deep learning does not work. If you have image data, if you have a voice data, if you have a video data, if you have unstructured text data like natural language processing, these kind of data, these kind of 4 kinds of data, deep learning neural network works fantastic. One reason, these are all digital data. Because these are digital data, you have millions of sample points you have, and hence a deep learning neural network model works very good. Because in a simple deep learning neural network model, if you say use Keras or a PyTorch, any deep learning architecture, your number of parameters in your model can, like the P, what we are talking about, can easily go up to 50,000, 60,000 very easily. And in fact, some of these chat GPT kind of models that are coming today, or GPT 3.0, they can easily have 1.3 billion parameters. Now, so naturally, you need lots of data to train these kind of models. So there is a trade-off between the number of parameters and number of instances. Now you take the, say, diamond data set, okay, or a simple sales revenue data set. And if you put deep learning neural network model, deep learning neural network model completely fail. Because typically what will happen, you will have too many parameters and you have a too little data set. And end of the day, what will happen is deep learning neural network completely overfit the data, and in the prediction, in the production, it will not be able to do the prediction that well. So classical regression models, classical machine learning models, like normal machine learning models like tree regression, decision tree models, random forests, support vector machines, simple machine learning models or simple regression models, logistic regression models still works well if the data is a standard textual type, like typical structured Excel type data. So it depends on what kind of problems you want to work on. If you want to work on more like a digital data, yeah, that is deep network models are the models to go. That is the hype right now. But at the same time, there is a normal regular data sets that is also a huge market. In fact, I think probably 80-90% of the market is still there, where the regular classical text, classical regression and classification analysis is still required. So that market is also there. I hope that's answer your question. Okay, so another question, how do we know that a model is overfitted or underfitted by linear regression? Once identify how to fix it. So okay, it was a direct message to me. So I will repeat the question. The question is, how do we know that a model is overfitted and underfitted or underfitted by the linear regression? Once identify, how we fix it. So I'm going to discuss this overfitting and underfitting issue in week 3 and week 4 mostly, in week 4. So essentially, if you have to split the data into train and test, and in the training, you fit the data, you see some of the, like one of the metric, say in regression case, it will be say RMSE or adjusted R square, and then to calculate the RMSE or adjusted R square in the out of the sample data set. And if they are in the ballpark in the same region, you can say that, okay, the model has done a decent job. If it is not doing so well, if the RMSE has gone up significantly or the accuracy has gone down, that means the model is overfitting. Okay, if the model is overfitting, that means some of the features is you need to basically what you have done is you have put some features which is very specific, which has become very specific to your training data set, correct? And now that feature is doing very good predicting inside the training data set. But in the out sample, that feature is not working, and that's why it is falling flat. So you need to maybe identify those features and have to do a proper model selection, and you have to increase the search space of your model selection and drop some of the features. You have to come up with a sparse solution, and that I have discussed in week 4. I'm going to discuss in week 4, and come up with a more parsimonious model, and then that hopefully will fix your overfitting problems. So Mohammed Askar, you are asking, will you cover ensemble technique in this course? So, okay. So idea of ensemble technique comes from bootstrap statistics. So yes, I will discuss bootstrap statistics in week, I think week 4 or week 5, I will see. And then from there, I will definitely discuss the idea of random forest and decision tree random forest, and of course, regression with random forest. So yeah, some ensemble techniques, not the entire, it's a huge area. Ensemble technique itself is a huge area, Askar. So I will try to give you the basic idea of bootstrap methodology. And then from there, I believe if you get the idea of bootstrap statistics, then you can put it in any, you can try to extend it into any other models. So I hope that answer your question. So there is another question. What kind of statistical approach you'd say is used while running experiment on data using deep learning model, frequentist or Bayesian? Good question. So both frequentist and Bayesian has some advantage and some disadvantage. And honestly, I don't have any favoritism against one over another. And though my training was in Bayesian statistics, my research is my Bayesian statistics, but I understand that frequentists also have some very strong technique to offer. So what I will typically do is I will try, when I have a statistic, I will try both frequentist approach and Bayesian approach, and I will see in out of the sample which approach is doing better. And obviously, even end of the day, I will settle down with that approach, which will give me the best predictive accuracy. Also, which technique is giving me a model which is more easily interpretable. Because one of the huge criticism of deep learning neural network model is it's a black box model. It's very difficult to explain what is actually happening inside the deep learning neural network models. And with any industry which is highly regulated, say banking and finance or pharmaceutical companies, there the first question a regulator will ask analyst that, do your model explain everything? For example, let me give you an example, and it will be clear to you why it is so important for the regulator. Suppose in a banking, a bank has created a credit, product, credit giving product, and they want to bring it to the customer. The first question bank will ask that, do your model has any kind of bias? And if bank will do some cross validation, and they found that bank is this product or this model is biased against the, say, female, okay, and the first thing they will ask that why your model is biased towards female, and you have to give a clear answer that here is the bias, here because of this part of my model it is biased, and how are you correcting for this bias. So you have to also give solution for that bias. But oftentimes for deep network models, you cannot even explain the model. So that is one of the reason I think deep network models are not very, so in industry like banking and finance, they are very careful about adopting these kind of models, including pharmaceutical companies. I'm not saying they are not adopting deep network models. For example, in the research side of deep learning, or if a bank is, say, developing a CRM product, say customer relationship management product, right? Where somebody is writing something in the chatbot, and chatbot is understanding it and giving answer to the customer, right? In there, they would love to use neural network model because neural network model is very, good in this kind of application. So yes, obviously they would love to use these things, but at the same time, they will be very careful. If you are giving a loan to somebody, and if you cannot explain why you're giving loan to this guy and you are not giving loan to, or you're rejecting loan application for another person, then you have to be very careful about whether your model can explain it or not. Okay, any other question? I hope that answer your question. Yeah. So can we, okay, here is another question that's sort of directly to me. Let me just repeat the question. Can we apply deep learning neural network concepts in predictive analytics in real life? I think deep learning neural network was extended from predictive analytics. So pretty much all the concepts that we are going to cover in basically predictive analytics are going to be useful in deep learning neural networks. And in addition, I think, yeah, I mean, I will, so yeah, I mean, I don't know why, I'm not sure what is your question. Neural network concepts in predictive in real life. I'm not sure what is your question, sort of.
So recommendation engine of the virtual assistant, we're using the deep learning, using the user's past history. That is also predictive. They're using the regression, predictive analysis, but in the deep neural network. I know this question. That's why virtual assistant Google keep on posting. Okay, if this person has purchased this order, then probably this person would like to have.
Okay, so can you hear what Kanika just replied? Kanika, you can just go to.
Hello. Okay, I'm not very sure, but there is a virtual assistant, like when you are purchasing one product in Amazon or any online purchasing, they would like to recommend you the same type of product that another customer has bought, and that customer, which type of product that customer is liking, they will keep on posted. If you are purchasing this thing, they will try to recommend you to purchase that similar kind of product. This is called virtual assistant. So in the virtual assistant, they are also using the predictive analysis in deep learning. So this is one example of that predictive analytics in deep learning we are using.
Okay, is that answer your question? Okay, I hope this session was useful. Okay, so Saurav is saying not very clear. Can you explain detailed manner if possible? So I am also not very clear what is your question. So let me just repeat your question. Can we apply deep learning neural network concepts in predictive analytics in real life? There are, I mean, predictive analytics is an older concept. Deep learning is newer. So it's like deep learning was kind of a generalized version of the predictive analytics. And there are a lot of concepts goes back and forth between standard regression analysis problem and the deep learning neural network. So my recommendation is if you go through, Tip Shirani's Elements of Statistical Learning, the book of Elements on Statistical Learning, you will see that there is a continuous development of deep learning models. So I'm not sure your question. What is your question? So sorry. If you can be a bit specific, that will be helpful. So recommender system uses predictive analytics. Natural language processing is the broad field associated with it. Yeah, I mean, recommender system.
Yeah, that is
Yeah, so the recommender system do uses predictive analytics, and natural language processing is broad field associated with it. Yeah. Any other question? Yeah, I understand that most of you want to learn deep learning neural network, but this course is not deep learning neural network. This course is on basically mathematics and statistics of regression analysis and classification, which is a building block for deep learning neural network. And I'm pretty confident the concepts that you will learn in this course eventually will become helpful when you will apply deep learning neural network, because deep learning, for me, to be honest, guys, deep learning neural network is just a model. It's just a bunch of equation put together, a model, and that's it. Yeah, it's very good model with lots of data. It do wonders, but it's just a model. It's just a bunch of equation to me. But conceptually, what is equation? We come from basic mathematics and statistics point of view. So I'm sure if you learn these basic steps, it will, going forward, it will help you to understand. When you will take advanced machine learning, kind of deep learning neural network models, that time it will be much more helpful. Yeah. Okay. Any other question? So if possible, cover some real world case studies in this course. Yes, that is our objective. So like Diamond's dataset was one, case, case study. So we are starting with small data set. We are going to a larger data set, and then definitely we'll keep giving you real world case studies. In pretty much every week, there will be some case studies that we will do hands-on, and in the next every week I will in my theory also. In theory, I will use small data sets because it helps to understand what is happening, the concept, theoretical concepts. But in the hands-on session, we will use larger data sets. Okay, larger big data set with real-life problems. Okay. All right, guys, I think if you don't have any further question, then I think we can close the session. Another question from Saurav Biswas. In predictive analytics, can we deal with unstructured data? No. In typical predictive analytics, in regression and classification, you have to do some transformation to put it into a structured data, and then only you can use predictive analytics. Any other question? Okay, I think if you don't have any question, then I think we can close the session. Okay, NPTEL team, I think thank you all for attending the session. I hope it was very useful, and see you guys in the next live session. And we will announce, we'll see the, I hope people have replied to the survey. We will see what is their best time they're giving, where most of the people are available. We will try to host the session at that time point, and let us meet in the next session. And meanwhile, every week we will keep posting the new lectures with the hands-on, and all the materials will be available as usual in the portal. Thank you all. Thank you very much. Take care. Bye.
Will generate questions generally.
यहाँ से ऊपर से पूरे से नहीं हो रहा है कल शाम हो तो अटक तक बता नहीं पा रहे लाइव पूरा होगा जो मोशन क्लास को ना उसके अंदर तक से ये जनरल है या गलत है इधर देखिए जनरल है दर्द 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 देंगे अभी तो नहीं लेकिन मैं और देख